So the purpose of this video is to give you a little bit more guidance if you're having problems getting started on the homework based on the previous video, or if you have gotten started but you're getting stuck. So I'm going to step through this process a little bit with a little more detail and use some examples in R itself. So the idea is to go through just one realization of what this Monte Carlo analysis on a linear regression is ultimately going to do. And the idea of this analysis is to create some artificial data with known statistical properties such that when you do a linear regression on it, you know what you should get. So in order to do that, the first thing we do is a vector of values that's going to represent the values for our independent variable, for our experimental units. And we can use a couple of different functions to do that, depending on the nature of those values that we want. So a straightforward thing to do, I'm going to start a new R script here, would be to just use equal intervals for that value. I'm going to start a new script here, so let me do what I usually do when I start a new script, and I'm working on developing a script, and that's do an rm list equals ls in parens. So that is telling R to remove everything that it finds in the global environments. That clears the global environment. And remember, we can always comment what our code does, and when you turn code into me, I'd like it to be pretty thoroughly commented. So as an example, I might add a comment here, clear the current environment to avoid artifact bugs. Because remember, the point of this is that it's easy to leave stuff floating around in your global environment that your script depends upon, but your script is not creating itself. And when that happens, if you shut down this session of R and bring your script up again later, it might not work and you're going to have a hard time figuring out why. So that this is just a way to make sure the global environment is clear every time I run the whole script and reduces the chances that there's something in there that's allowing my script to work when it won't work the next time I try to run it. Okay, so I'm going to go ahead and call this variable x, since I've been calling my independent variable x. And a simple way to create a vector of values for x within some range is to use the seek function. And whenever you need help with a function, you can always do a help. And it will give you some idea of the nature of what the function does and some hint on how to use it, as well as a description of the arguments that the function needs. So for a sequence, I say I want numbers between 0 and 10. So I can give it the argument from 0 to 10. Then I can either tell it what size the interval should be, or I can give it a length out parameter, and that will just tell me how many, or just tell it how many elements should be in the vector, and it will adjust the length accordingly to be at equal intervals. So if I run this, I can look at x and I can see that I have 20 elements in that vector, and the elements are spaced equally between my from value and my to value. If you want to get fancy, you could do something like RUnif, which stands for random number from a uniform distribution. This is a random number generator that will pick a number randomly between a minimum and a maximum based on a uniform distribution, meaning there's an equal probability of any number between the minimum and maximum being selected. So if you want your x to be more randomly distributed over some range, that's another choice that you might take here. Okay, we have our independent variable in a vector that we've called x. The next step is to generate some sort of idealized prediction based on our model with known parameters for the slope and the intercept. And we can just use vector math for that in R. I'm going to call what comes back from my model, f of x, since that's what I've been using in the slides. And I can just say that, well, this is going to be my intercept plus the slope times my x vector, my independent variable vector, that is. Now notice that I haven't put numbers in here, I've just put intercept and slope. That's because I want to make it easy for me to change the intercept and slope throughout this whole script. So I'm just going to define those as variables at the top here. Let's say my intercept is going to be, intercept is going to be 5, and my slope is going to be 2. So recall with vectors, the way mathematics works is it's going to recycle shorter vectors in order to cover all the elements of a longer vector. Both the intercept and slope here are vectors with just one element, but x is a vector with 20 elements. So this multiplication is going to be carried out 20 times, recycling this one value for slope for all 20 values of x, and then that's going to produce 20 values, and then the single value of intercept will be recycled 20 times to be added to those 20 values, giving us a vector of 20 values for our modeled version of y. So I can run that, and I can look at y, and I'm sorry, f of x, and this is going to give me 20 elements with values that are based on my model applied to my independent variable, which is this vector between 0 and 10.